Hi, everyone. Today I'm defending a churn prediction model built for a telecom company, specifically why I believe it's responsible, fair, and safe to deploy. I'll cover two things: how I ensured the model follows responsible AI principles and addresses fairness, and what methods I use to make it interpretable and why that supports ethical decision making. In this dataset, 26% of customers churned, roughly 1 in 4. The goal is to identify who's about to leave so we can intervene with a retention offer before it's too late. But a model like this has real power over people. If it's biased, certain groups get treated unfairly. If it can't be explained, it can't be trusted or defended. That's what responsible AI is about, and that's exactly what I'm going to show you we addressed. I built this model around 3 RAI principles. Fairness. The model must not discriminate. Predictions must be equally accurate regardless of gender or age, and I tested this with actual numbers. Second is transparency. Every prediction must be explainable. The algorithm said so is not an acceptable answer in a business or regulatory context. Finally, accountability. Guardrails must exist. Human review for borderline cases, regular audits, and clear rules about how predictions can and cannot be used. These aren't just good ethics, they're good business. A model that can't be explained can't be defended. I trained 4 models. Random forest has the highest accuracy of 78.4%, but I didn't choose it. I chose logistic regression at 74.7%, and here's why that's responsible. Accuracy is misleading on imbalanced data. 73% of customers don't churn, so a model that has a predicted no churn for everyone would be 73% accurate and completely useless. So what matters here is recall. How many actual churners did we catch? Logistic regression catches 77.9%, and random forest only catches 45.2%. Despite its higher accuracy, random forest misses more than half the customers we needed to save. So now, if the retention offer was very expensive, we would weight precision more heavily, since precision controls how often we waste offers on loyal customers. Random forest 63% precision versus logistic regression's 51% would tip the balance the other way, but the right metric depends on the business cost of each error type. And I chose recall because missing a churner costs more than a wasted offer. So beyond recall, logistic regression also has the highest ROC-AUC at 0.8448, the best overall ranking performance across all 4 models. But the most important reason is transparency. Deep learning, that can't be explained. Like black box models that affect individuals face real regulatory exposure. And logistic regression lets us trace every prediction back to specific features with specific weights. That transparency is worth more than any marginal accuracy gain from a model we can't defend. Now, the fairness testing. This is where I prove with data that we took bias seriously. I tested 2 protected groups, gender and senior citizen status. For gender, demographic parity difference of 0.017 equalized odds of 0.040, both well under the 0.05 threshold. The model treats male and female customers equally. Now, for senior citizens, a demographic parity of 0.238, that's 5 times over the threshold. Equalized odds of 0.178, 17.8%, that's 3.5 times over. So in plain terms, seniors are being disproportionately flagged as churners in a way that isn't justified by their actual behavior. And this happens because seniors are only 16% of the training data, and they tend to have month-to-month contracts and no tech support, which are strong churn predictors. So the model picks up on those correlations and effectively penalizes seniors indirectly. That's called proxy discrimination, and it would go completely undetected without deliberate fairness testing. So finding this is a success, not a failure. Responsible AI means surfacing these issues before they cause harm. So this model cannot go into production as is because 3 things need to happen first. One is threshold optimization using FairLearn. So setting separate decision thresholds for seniors and non-senior customers to equalize error rates. No retraining needed, implementable before launch. And 2, is quarterly fairness audits. We need to rerun these metrics every quarter since customer demographics shift over time. And then third is just more representative training data, oversampling the senior group in future training rounds for a long-term fix. So on to interpretability. The Shat bar chart shows the model globally relies on and to make predictions. So the top findings is we see longer tenured customers are far less likely to leave. We see that 2-year contracts are strongest churn protector. So commitment drives retention. We also have monthly charges push churn up. Higher bills mean higher risk. Then there's fiber optic customers churn more. So worth investigating for service quality issues. And of course, there's tech support reduces churn. So suggesting it should be bundled into retention offers. These aren't just interesting data points, they're a strategic roadmap for a retention team. So for global explainability, this tells us what the model generally relies on. Local explainability tells us why it flagged this specific customer. So here, the shape waterfall breaks down an individual prediction. So each feature's contribution shown as a red bar, red pushing churn probability up, blue pushing it down. A retention agent can look at this and know exactly what to address in a call. I also ran counterfactual explanations, which answer the question, what's the minimum change the world would what's the minimum change that would flip the outcome? For a customer with a 99.8% predicted churn probability, switching to a 2-year contract drops it to 17.6%, an 82% reduction from a single change. By reducing monthly charges by 50% only brings it to 96.2%. So that tells the team a contract conversation will save the customer. A price discount alone won't. That's the difference between a prediction and an action plan. It's also what allows us to be transparent with the customer about why they were contacted. So interpretability is what makes ethical oversight possible. Without it, bias goes undetected. With it, we caught the senior citizen issue. Human reviewers can understand borderline cases, and customers can be given real explanations, not just the system flagged you. My 5 deployment guardrails are human review for predictions between 40 to 60% probability, no punitive use. Predictions must never restrict services or raise prices. And then customer transparency via counterfactual explanations, model card documenting all limitations before handoff, and quarterly re-audits. So to close, what we built was a logistic regression. Best AUC, best recall, fully explainable, paired with shape, lime, and counterfactual analysis. What we proved was the model's gender fair. Senior citizen bias was found, quantified, and a fix is defined. Contract type is the number one retention lever. A 2-year contract switch cuts churn probability by 82%. So what comes next? Threshold optimization, quarterly audits, model card, and human review process. The bottom line is a model that's accurate but unfair is not a model worth deploying. We know exactly where this model's weaknesses are, we have a plan to fix them, and every prediction it makes can be explained. That's what responsible AI looks like in practice. Thank you.